Hello everybody, I'm going to be doing 6.2 for Algebra 2, Inverse Functions and Relations. Again, this is being posted after I have already posted all the 6.4 to 6.6 items, and it is by special request, and so here we go. 6.2, Inverse Functions and Relations. We have to understand what an inverse is, and it is the set of ordered pairs obtained by exchanging the coordinates of each ordered pair. So that means that if A, B is our coordinate, we're going to exchange those coordinates and they're going to become B, A. That's kind of the gist of inverse functions right there. So if statements here, if then statements, f of x and the inverse of f of x, if those are inverses, then f of A equals B, and the inverse of B equals A. The inverse is actually a reflection, so it's a reflection, if you remember that term from geometry, over the line y equals x. And so again, you would exchange those points in geometry when you were supposed to reflect a point over the line y equals x. You exchange the points because if y equals x, then x equals y, and both of those are exchangeable. How we, again, you've already seen me write it here, how we write the inverse function is the inverse of x. So it's this little -1 right here that you see. And so that denotates the inverse of something. Now, we're going to be just going over how to find the inverse of functions. So I can show graphs as well, and I'll actually show those at the end. But the inverse of a function, you're going to actually exchange the x and y and then solve for y. So I'm going to be having an example right here. Let's go example, not sure how many I'm going to do, but example, let's go y equals 3x plus 5. And I want to find the inverse of this. So find the inverse. What I'm going to do is switch the x and y. So I'm going to go x equals 3y plus 5. And I'm now going to solve my equation for y. So that means I'm going to subtract 5 from both sides. X minus 5 equals 3y. And divide both sides by 3. So that cancels out, and I'm going to I have a y equals x minus 5 over 3. This is actually my inverse. Right there, that is my inverse. So let's try another one. Example now 2. So this was example 1. Nice thing about permanent markers, it doesn't even look like I made a mistake. Example 2, let's go f of x equals, let's go 1/2 x plus 8. Now I'm making these pretty simple because I don't want to confuse you anything and I want to give you pretty simple examples. I want to exchange now, I'm going to rewrite this as y equals 1/2 x plus 8. And I'm going to switch my x and my y. So x equals 1/2 y plus 8. All right, I'm going to subtract 8 from both sides because, again, I want to solve for the y value. X minus 8 equals 1/2 y. Well, to now solve, I need to multiply both sides by 2. And I multiply everything by 2. This cancels out. I am left with y, and I'm going to distribute over here, 2x minus 16 equals y. So my inverse of x equals 2, I will write, yep, 2x minus 16. I'm sorry, I was deciding which way I wanted to write it, but 2x minus 16. And there we go. All right, that is the algebraic ways to solve for inverses. I am going to just kind of bring you over here real quick to my actual, what was going to be my in-classroom notes. And as you can see right there, a couple of inverse graphs. But when you are looking for an inverse, and so given the function g of x graph below, find the following. Well, the inverse of 2, this is saying when y equals 2, where is x? So instead of how we usually look at, so let's take, if this g of 2, this is when x equals 2. Well, we go to when x equals 2, where is y? Y is about 0.5, right there. But this inverse is asking when, and we'll go back to the first one, when y equals 2, where is x? So we go to when y equals 2. This is the y-axis right here. When y equals 2, where is x? Well, x is 4 different things, actually. X is negative 4.5, negative 1.5, 1, and 4. So all 4 of those are my answers because this is asking me when y equals 2, what is x? So whenever you see an inverse, ask yourself, when y equals that number, what is x? When you see a regular function, when x equals that number, what is y? Hopefully that helps to explain the graphing side of it as well.